Yeah, what are we doing today? Well, today we're going to be looking at Python states in Houdini, and I wanted to run through an example of building one of those tools. So you might have seen some of the tools that I've been tweeting about on Twitter, where I showed a box cutter tool and a trim texture tool and a pick and place tool, like a tool where you can basically just place objects in the scene interactively. And that's basically what Python states are all about in Houdini. So Python states allow you to control interaction within the viewport. So like the documentation says here, the rotate tool, like the rotate handle, is a view state. It's a state in the viewport that allows you to control things in the network editor, in the parameter interface. It can show handles, right? It can interact with geometry. So I can, for example, cast a ray into the scene from wherever my mouse pointer is, and get information from polygons that I'm hovering over. I can display guide geometry. So if I, for example, want to show a wireframe of some geometry, on the side of some geometry or something like that, I can do that with Python states as well. We can select geometry, just like, a selection state, which once again is also a state allows you to do. We can create custom right-click menus, and most importantly, we can respond to low-level mouse, keyboard, and tablet events. So we can do cool things like, let's say I'm working in the bevel tool, and I press the letter B, then it's going to modify a certain parameter value on my bevel node. So this allows you to really customize things inside of Houdini. Then there's of course some more low-level stuff like wrapping stuff into undo blocks. We won't get into that today because that's more advanced than what I'll be showing today. But this page here shows all the different sort of things that you can add to your Python states, like creating a nodeless state, which is essentially a state that you can enter without having to explicitly create a node for it. Like for example the view state, right, which is what I'm in now, where I can just move around like this. That's the view state, which is nodeless, right? There's no camera node that is controlling the interactions that I'm doing here. However, the extrude node, not the old one, that one, is a state that is bound to a node, right? Because the extrude state is only really useful or used within the poly extrude node. So that's that. Let me see, what else are we going to be looking at today? I'll be showing a quick example of handles. I'll be showing user interface events, of course, context menu, which is the right-click menu when you click in the viewport, and some more awesome stuff. So before we get started with building one of those states from scratch, I want to show what is possible with Python states. So this is one of the tools that I built with Python states, which is a trim texture tool. And a trim texture tool allows you to interactively assign UV shells from a trim texture onto geometry. In this case, this bench that I've been using to test and build this tool with. So the first thing you'd be doing is, of course, assigning some UVs to your grid, which is what we're seeing here. And then, as you can see, I took this grid and I cut it up so that the edges that I generated match up with the texture, right? So that once I get into the trim texture tool, I can just say, click on this piece and assign it to this piece. Click on this piece and assign it to that piece. And that's where I created this utility tool for, which also is using a Python state. And, creating these multiparms and manually setting selections and having to click this every time and hitting enter and then, clicking again and hitting enter, that would be quite boring, right? But that's something that Python states can really help you with, where if, in this Python state, I can just say, if I click and I release, then it's automatically going to add a multiparm entry and set it to whatever the primitive number is of that primitive I just clicked, right? And it's going to do that every single time that I click. That's what I told the Python state that I wanted to happen, which is what I programmed. And as you can see, a few lines of Python code make stuff that previously was really boring and repetitive very, very easy all of a sudden. Yeah, let's take a look at the actual the cool tool, which is the tool that does the assignment. So if I select my node, which is important, right? So Houdini knows which node to invoke the state from, and hit enter, we can see that I'm now in my custom state, which I named lab stream texture. And now what I can do is I can click on any of those primitives and do a highlight on them, so that I can just click on one of these shells and then just click on the geometry to assign the UV shell to the place that the trim texture has its UVs on, right? Which allows me to UV this object really, really easily. If we're doing somewhat more advanced stuff, we can also add stuff like doing combinations of keys. Like, for example, holding the shift key. So if I hold shift and I click once and click again, you can see that it's automatically, appending whatever selection or click that I'm making to the previous entry of the multiparm, which allows me to, unwrap, a couple of primitives together as one. So then for even more interactivity, what I can do is just right click to show that context menu that I was talking about and change what sort of tweaking mode I want, which then allows me, by holding the middle mouse button, just modify a parameter that I created on my, my interface. Just set that by just moving my mouse, right? So in my Python state, I'm grabbing the mouse position, comparing it to the previous mouse position, and then, set a value from that. I can, of course, also allow it to rotate, which allows me to, customize this even more. Or if I'm not happy with the scale, I can just, use the middle mouse button to adjust this here. All right, so as you can see, something that was quite boring and took lots of handles and whatnot, you can do very, very easily with Python states. Let me see if there was any questions. This is my first live stream, so I gotta get used to reading the chat. Any chance of this ever working with Houdini engine like Unreal, or does this only run in Houdini? Yeah, so the stuff that the Houdini engine plugin supports is really dependent on the platform the plugin runs in. So for Unreal, for example, Unreal doesn't have what the box op, for example, has, which is this six-sided handle allowing me to do this kind of stuff. Unreal doesn't have the functionality for this kind of stuff. So I wouldn't be able to use that in Unreal, and neither does it have any of the logic that I use to create these kind of states. So no, that's not really possible in Unreal. There is, however, something that will be showing soon with the Unreal Engine v2 plugin, but that's all I can say about that for now. All right, so that's the trim texture. That's one example of what you can do with it. I guess one thing else that I wanted to show is this texture thing that I'm floating here in the viewport, right? Python states in Houdini, the drawables, which is what I'm using to create these highlights, don't support any shaders yet, right? So I can't assign a material to my my drawable yet. So how do I get this thing here? Well, if you dive inside this tool, you'll see that it's actually quite a dirty trick. I'm just taking that that input texture or piece of geometry which has that shader attached. I offset it a little bit from the origin, which is the offset I have on screen, and then this transform node, all it does is literally just grab the transform of the viewport camera, and that allows me to stick it on top of it. And then I have this switch which turns on and off depending on what it is I'm doing in my state. Like when I hold Alt, for example, which is when I go to the view state, that switch goes to the null, and if I release it, I go back to the geometry. Okay, so let's take a look at another tool, the pick and place tool, which is also, probably the easiest tool I've done so far with Python states, which is also the tool we'll be building today, which allows you to interactively click and drag in your viewport to create objects like this, right? Where I can move them around. I can, enable snapping for example, the scaling, like this in increments or 1, or add snapping for the rotation. And once again, all that the state is doing is just setting parameter values here. All right, let's see the chat. Right, what happens if I press W? yeah, so it's just geometry you're seeing here, right? So inside of this node, it's not all the logic is not all done in Python, right? All that's happening is I built my network, right? Which does whatever it is my tool has to do. And then it reads the parameter values from the top. And those parameter values, instead of, having to go here and sliding with them, that's what I'm setting through Python states. Yeah, so that's the same, like Jake says, that's the same for all the other tools. All right, I guess the moment has arrived. We'll be building one from scratch. Let me just save this as streams, Python states, and let's just call this version 1. Cool. So how do we get started? Like I said, first we need to build a network. So we're going to be building that pick and placer tool I mentioned earlier or just showed. So first we need to create a little terrain to be painting on, of course. So I think this grid will suffice. Then we're going to need a box. And that box I want to be placed at the origin with this pivot at its at the bottom of it, its center. So I'm going to be using this axis align node from SIdeFXLabs, which allows me to just automatically, without using a transform node, align the node to be centered and have its pivot at the bottom. Yeah, so next up, we're going to need an add node because we need a point to be drawing with or copying stuff onto, right? So here's our point. And all we're really going to do is do a for each loop, set to number. We'll see in a bit why it's set to number. And we're going to add this node in like that. And then we plug in this guy into another input, which is going to fetch the input. There we go. Oh, actually, we don't need this guy here. And then we have a copy to point at the bottom. So we're going to be generating points for every entry of the multiparm. And then we're going to be copying the box onto it. Okay. So that now we have one box as soon as we place that point. And of course, what we want to be able to do is modify the position. But instead of having to go here and modify it, we want to set that using the Python state. All right, so let's create an HDA for that. Select all of our nodes, and we're going to go assets, new digital assets from creation. And we're going to call this one Python states stream. Why not? And just save that in my docs. That's fine for now. All right, so now we have that. And we have one input at the moment, but we want to have multiple inputs because we want to be able to draw on our terrain. So we're going to say minimum inputs to 2 and assign that. I'd like my primary input to be the terrain, and the secondary input will be my grid. It's going to mess up the copy to points, of course, but that's fine. So let me just quickly rewire that. So we're going to want to have this one. And of course, as always, add an output SOP so that Houdini will always produce that to be the output. All right, so what do we have to do first? First off, we want to just start simple, and we're going to want to control the position of the point. And for that, we're going to be just calling this one V for vector, and we're going to call this one position. And then we're going to call this one, for the label, position as well. All right, cool. Start. I'm going to add an underscore so that later on, once we modify this to be a multiparm, actually, let's do that now. Why not? Let's do this placements, and we're going to call this one I placements, and this is going to be a multiparm, and we're going to add this guy in here. All right, so now we have our multiparm with positions. So now, as you can see, we have 5 entries with all the position being 0. First thing first, I mentioned we have a for each loop running over count, and the reason we did that is because we wanted to be running the number of times that we have entries for the multiparm, right? So if we middle mouse on this guy, we can see that we have 5 points. If we copy 2 points, we'll have 5 boxes placed at the exact same place because we don't modify any of the positions yet. So what I'm going to be doing is grabbing the value from the multiparm above. And I'm going to do that by first storing it in this wrangle because I don't really like HScript's expressions. And we're just going to say, first we're going to figure out which iteration we're in. So I'm going to say int iteration equals detail 0. This annoying bug. 0 iteration and grab this like that. All right, so what I'm doing, I'm grabbing the detail attribute that's stored on the meta input node, which has iteration, which will keep track of which iteration we're running over, right? Because if we have 5 multiparm entries, we want to know which one is it that we're going to be grabbing from. So if we just do that. All right, okay, next up, we want to be grabbing the position, of course. So we're going to say vector pos equals, we're going to be grabbing a channel vector. It's printf because we're going to be merging some text. I'm going to say dot v position underscore, and then we're going to say G like that, comma, and then we're going to be using iteration like that, and that will be giving us the position. Next up, we're going to need to set the position that we grabbed on this add wrangle. So I'm going to do right-click the parameter, go under reference, and click scene data. And then instead of finding a node here, I'm just going to be clicking on the node that I have here, which will automatically find it in this menu for me. And this wrangle, let's see, global. Oh, I know what I did wrong. This needs to be detail. So let's do that again. Reference, scene data. Click on our node, go to attributes. We want to be getting the global attribute, which is the detail attribute. And then we want to have the, oh, it didn't store it as a v-at, right? Otherwise we can't access it. Attributes, global, position. All right, there we go. So now we should be getting the value of the multiparm. So if we now modify any of these guys, we can see that they will be grabbing the values from the multiparm. Oh, and I think we need to add one because iteration starts at 0. Yeah, there we go. All right, cool. Now we have that. So we have the basics for our Python states tool already. So how do we, let's check the chat actually before I forget again. Yeah, it will be recorded. I'll be releasing it unless I screw up too big. All right, no questions yet, it seems. All right, so to create a Python state, which is what you're all here for, we're going to be right-clicking and hitting Type Properties. Then under the Interactive tab, we have this new little tab here, which says View States. So what we're going to do is we're going to click New, and that's going to allow me to create or select a template I want to be creating a tool from. So what I'll be doing is creating one from, let's say, add point. Why not? So that's going to, as you can see, already pre-select some of the functions that Python states allows you to use, like the onEnter, onInterrupt, onResume, and onMouse event. Which is what we'll be using for most of of this tool, right? Because we want to modify something as soon as our mouse moves. So if you hit accept, we can see that it already generated this nice template for us. And if we then hit apply and accept, that's now saved. So to modify that, you can use the latest labs edition from Guillaume Jobst. which allows you to just right click and hit here, edit extra section source code, popping up this window allowing us to, you know, get all the extra sections scripts, like for example the ones stored in the onCreate or onloaded, unupdated, or any of the extra files ones, or once again the Python states one. So I'm just going to select the one called viewer state module, which is going to open it for me here in Sublime, which is the text editor I'm using. And I'm just going to do some cleanup because I don't want everything that it has by default. We're not going to need this. We're not going to need this. Let me delete all this stuff. On enter. Yeah, okay, this is just going to set the prompt message. On interrupt, on resume, fine, on mouse event. That looks cool, that looks cool. All right, so let's delete all of this stuff so that we have just, you know, our empty state. I could have probably also just, you know, taken the empty template, but I wanted to show some of the stuff that gives you, some of the templates gives you. All right, so what do we want to do? We want to, first of all, just as soon as we enter the state, I want to add an entry to the multiparm. We're going to get some errors because I deleted code. It doesn't quite like that. So let's see what it's complaining about. On line 33, yeah, we don't have that thing anymore. So I'm just going to remove that and hit save. And also another cool thing about this thing that I just showed you by right-clicking and, you know, selecting this thing, if you modify your code here and hit Control S, which saves it, it will automatically update the code that you find here. And the same goes for a wrangle, for example. So if we, you know, right-click this wrangle and say expression, editing external editor, and we type something here and hit Control S and close this, we'll see that it automatically updates here. Oops. We'll see that it automatically updates here. So if you're wondering why I'm not copying paste, that's why. So let's go back to our viewer state. Hit Control S, and let's enter our state. All right, so no more errors. We can now finally get started. We don't want this stuff either. All right, so once we enter our state, we have some variables here that, you know, get initialized, and these two are the default ones that always come with a template, which is a state name, which is the name that, you know, the state has so that Houdini can open it, and a reference to a scene viewer, right? So that we know what viewer we're working with. Then we of course want to create a reference to a node because, you know, we'll be modifying parameter values stored on this node, and instead of having to find the node every time, it's just better to keep a reference to it. So as soon as we enter the state, this callback gets called, so the onEnter. And as you can see here, we're setting the node variable to be, you know, one of the attributes stored in quarks, right? So we have a reference to our node. OnInterrupt happens as soon as we, you know, press Alt. So let's just try and showcase that by just saying interrupt and hit save. And so let's showcase that. Now, as soon as we enter our state and we, for example, hold Alt, we can see that it prints OnInterrupt, right? So that happens as soon as we go into the view state mode or something like that. Let's remove that for a second. On resume, this is the opposite. So as soon as we release Alt, that's when on resume gets called, right? So as soon as we leave either a selection state that we added in or, you know, the Alt view state. Next up, on mouse event, which is an event that happens every single time that, you know, an event happens with the mouse. Like, for example, us moving it in a viewport, right-clicking, middle mouse button, left mouse button, right mouse button, anything else like that. So what do we want to do? We, of course, want to be casting a ray into the viewport from wherever our mouse is and collide with whatever the terrain is. So first thing I'm going to do is get this input here and merge it with the output so that we can see what it is we're painting on. Like that. So that now we have our terrain and no box is painted on it yet. But I also want to create a null here that I'm going to be sampling from and storing in the Python state. So I'm just going to call this one terrain. No, not with one R, with two R's. so that in my Python states, I can grab the geometry value from this guy here so that we can collide with it. So let's do that. Let's go up here and store it so that we don't have to grab the geometry every single time that we update or move our mouse. That would be quite expensive. So I'm just going to say self dot collision geo, and we're going to set that to none to begin with, and then let's set that value on the on enter. So we're going to say self dot collision geo equals, and then we're going to grab the node data inside of our HDA, right? So our HDA is this self.node, the reference we stored. And then we want to grab a node inside of it, and we can do that by just typing .node, and then copy this guy's name here. All right, so just say that, like that, poof. And then to prove that we have it, let's just print this guy here, like that. Right click, hit save node type, and hit Control S in case we crash. And as you can see, whenever I now enter my state by hitting enter, it just prints out the name of the node that we have, or a reference to the node. In this case, we don't want to have just the node, we want to have the geometry. So what we can do is we can just grab the geometry like so. And now when we enter our node state, we can see that we have a reference which is read-only to the geometry of the terrain that comes in, which is this grid here. And that's going to be very useful for us because we're going to need to collide or cast a ray and hit it, right? So that we know where it is we hit it. So to do that, I have this really nice sample code file that I have, which allows me to just copy some code so that I don't constantly have to go to the documentation and grab it. So what I'm going to be doing is copy these lines of code and go back to my Python state and just paste it in there. And I can probably just share this one afterwards, but you can find the same code in the documentation. So what I'm doing is I'm going to be creating a geometry intersector, right? Which is going to be testing intersections with geometry. And the geometry we're going to be colliding with or testing against is this guy here. So we're going to copy this and paste this in here, so that our geometry intersector is going to intersect with our collision geometry. And then for our scene viewer, as you can see, it will just take our scene viewer so that it knows where it's intersecting with. And then we have our gi.intersect function, which is just going to do an intersection test, like just like you would do in a Wrangle, casting a ray from the origin, which, as you can see, is the UI event.ray, which is the origin of the mouse in 3D, in world space, right? So wherever our mouse pointer is floating in 3D space. Looks 2D for us, but in reality, it's 3D based on where our camera is. And then a direction, which is just a ray from our mouse straight down onto the grid. Then we have access to a bunch of attributes of this geometry intersector, like for example, whether or not we're intersected, whether or not, what the position is of our intersection, what our normal is of the intersection of the geometry, of the primitive that we hit. We can get our UVW coordinates of the intersection that we can use to interpolate some attribute values with. The primitive number that we hit, the actual geometry used, which is the one that we fed in, so not as useful for us. Ray origin, which is going to be the same as the origin and the direction that we hit in or put in there. All right, so let's start simple and just checking whether or not we intersected with our geometry. And so to do that, we can use one of those properties that our intersector gives us. So what we can do is just say, if our geometry intersector dot, the primitive number that we hit, if that is smaller than 0, which means it's -1, we didn't hit anything, right? So in this case, we want to make sure that we did hit something. So if it's if it's larger or equal than 0, we're just going to print I hit a primitive, and then hit save. So as soon as we now do something here, it's probably difficult to see, but as soon as we hit our geometry, we can see that it's printing that it hit a primitive, right? So next up, what we can do is get the position of that primitive that we actually hit. And so to do that, we can store our position of what we hit. We can say position, or hit, let's call it hit position, that's easier. Hit position equals the geometry intersector, and then we want to grab the position of what we hit. And it's important that we do that after we check what we hit, or whether or not we did hit something, right? So that we're not going into some sort of error state. And so what we're going to do is to prove that we're indeed updating this every single time we update our mouse. Let's now just print that hit position. So as you can see, I'm not hovering over the geometry yet, so we're not printing anything. And as soon as we move over it, we can now see that we have the position of wherever our mouse, ray intersects with the geometry. Next up, instead of just printing this stuff, we want to do some useful stuff with it. Printing is great for debugging it, but we want to add it to our multiparm, right? All right, so first up, once again, let's add a copy of our multiparm, or a reference to a multiparm. And let's just call this self.multiparm equals, and let's just initialize that as none as well. And then once we enter our node, we're going to be setting that. So self.multiparm equals self.node, right, which is the HDA itself. And then we're going to be grabbing a parm, which is a multiparm, and we called it, let's see, I, and then placements. I placements. All right, let me check the chat to see if there's any questions so far. Unless I decide to disable it, what am I disabling? That's a question for the max factor. Oh, right. If his stream is going online, yes, it's going to be online. All right, so we have a reference to a multiparm. And as soon as we enter our state, I'm actually also going to want to add an entry to a multiparm. So we're going to first up check what the value is of our multiparm by just saying number of entries of our multiparm. And that's going to be, just like you do in a Python SOP or anywhere else. Since we have a reference to a parameter, we can just say dot eval as int, which is going to give us that value. And then we're going to be setting the value as well by just saying self.multiparm.set, right, to set it. And we're just going to say number of entries plus 1. This is not the best way of doing it, of course, but I'm just going to keep it simple for this stream. Which means that now, as soon as we enter our state, we're going to have a thing being added. This is, of course, going to add it every single time that we hit enter or enter our state. But we'll change that later on so that it is going to remove it if we haven't actually placed an object yet. So that way we can move around our object and only keep it when we actually placed it. So we have our multiparm, and I'm just going to copy this code here. Or actually, let's make a function out of it, because then it's easier to call. So let's call it of multiparm entries. We're going to call this one self, and then quarks. All right, cool. Like that. And then we're going to return this. Cool. So that now, instead of having to type this every single time, we can just say, get the number of multiparm entries and then store it. So instead of having to type the code all the time, we can just call this function. All right. So instead of just printing the function, let's set the latest multiparm entry through Python states. So we're going to say we have our position. So let's first get the number of entries again. Num entries equals, and then I already forgot the name of the function. Copy this guy here and feed in our quark so that we don't crash or don't get any errors, which will allow us to get this. Next up, we're going to set it. right? So we're gonna say self.node.parm, and then we're gonna grab our parameter here. And as you can see, it's a tuple. So instead of grabbing all the individual components, we're gonna just grab the tuple. So we can say grab the parm tuple, and then we're gonna grab the position underscore, and then I'm just gonna use this notation. I know some people are gonna hate and say I should use Python 3 already, but you know, not yet. And then we're gonna say number of entries. There we go. So now we have a reference to our parameter, and we're gonna want to set it. So we're gonna say set, and then we're just gonna say set that to be the hit position. So if we save that, and yeah, we did remove the print, and hit enter. Oh, of course we need to say self, because we stored it in our class. Same up here. Like that. Mistakes happen. What happened? Oh, of course. There. All right. So now, as you can see, my geometry is following the mouse cursor, but it only does so when we hover over our geometry, right? So as you can see, if I don't hover the geometry, it doesn't follow it. If I do, it keeps setting that parameter value by wherever my mouse position is, because of this check that we did, right? We make sure that we only place it when we check something. So what we could, for example, do later on is, not show this guy or hide this piece of geometry when we're not hovering over our geometry. But having a piece of geometry stuck to our mouse cursor isn't really useful. So what we're going to want to do is add the ability to just place it. And the way I'm going to be doing that is by getting whenever we hit our mouse button. And the way we can do that is by using this reason parameter, which is what you can get from our UI event, which holds all the UI events that happen in the viewport. So I'm going to copy this guy here and place it up here so that we have reason. And we're also going to be copying this guy here, picked. And picked means that we just did a single click in our viewport with our mouse cursor. All right, so if our reason is picked, we're just going to print single click. Show if that works. Click, every time we click, it just says single click. All right, so the easiest way for us right now to just freeze the piece of geometry whenever we click it is by just incrementing the multiparm entries, right? So what we can do is copy this guy once again and say the multiparm, get the number of entries of our multiparm, and just set it to be increasing by 1. Just save that, click and close. And now as soon as we click it, voila, we can now just place pieces of geometry. And as you can see, we're not colliding with any of the other geometry, because what we're using or testing against with our collision geometry is this terrain piece here. Okay, so how do we get it to collide with that piece of geometry? Well, we can do that by instead of testing against this guy, test against the result of our copy to points and our terrain, right? So this guy here. So let's copy this guy here and just say that we want to call this node here complex collision, and just paste that guy over there. So you might be wondering, will this work straight away? Well, the answer is no, it won't, because of a pretty simple thing. If you look at how this system is set up currently, the for each loop will run over every single entry of our multiparm, right? And that's not going to work, because then we're going to run into some recursive problems where the box that we're trying to move around, that we're also trying to collide against, doesn't exist yet. So one way of doing that is by actually taking this multiparm or this for each loop, and instead of looping over every single iteration, we can just loop over all but the last one. And then just test against that. So hit, let's do that. And instead of testing on that guy, we're going to be testing against our complex collision. All right, so this is probably going to fail. We won't see the last one, of course, but we'll fix it in a second. And as you can see now, of course, we're not processing the last entry of the multiparm, so we don't see our geometry yet. But now we have our really simple box stacking tool already, right? So there we go. Now we can just click on all the previous geometry that we made and collide on that. So is this the most efficient way of doing it? No, it is not. Because we're basically doing this entire process every single time, all the copying, every single time that we add a new entry to the multiparm. But we can optimize that. I won't show it how to do that exactly or build it myself today, but I'll show you how you can do it instead, which is a cool little trick I learned from the point weld SOP in Houdini. And what we'd basically be doing is, we'd have the same loop that does all the copying and uses all the parameter values from top, but instead of getting that updated geometry and testing against that every single time, what I'll be doing is the very first time you do an action, it indeed does this loop, but then I grab the geometry from this guy, a copy, and I just store it in this stash. And then every single time after that, instead of testing against this geometry that's constantly updating, I'll be just testing and modifying this stash geometry that I'll be doing. So it's taking this stash node, which has all the previously modified geometry, then do one step or one click of my trim texture tool, and have that be the output. And as soon as I've done or completed that step, then it's going to save this guy's output and just store it in the stash again. So that way, the only thing that Houdini or my Python state has to cook every single time is the very last step that I'm actually doing. And then I have this switch if node that checks whether or not there is geometry in here in the stash node. If there is none, it is going to do whatever is stored in this for each loop, right? Which is every single entry in the multiparm. So that later on, if we exit our state, all of the parameters, all the entries in the multiparm are actually live, right? So that's the real benefit and power of Houdini. All of that is live. There's a question, wouldn't stash bloat hip files over time? Yes, it would, but it would only do that during while the Python state is active, right? As soon as I leave it, I would basically set the stash to be empty again, which would tell this switch that, don't show this guy's geometry, but show the geometry from this multiparm, which, one, allows it to be live, and two, allows it to, not store any data inside of the hip file itself. Any other questions that I can quickly answer? I can see that Marc Andre is in the chat as well. He's the actual developer of Python States, working on it. So shout out to him, and many thanks for the help I get from him all the time. All right, so let's go ahead and fix the problem of not being able to see our last piece of geometry. So what I can do is just copy the node that I have here, or copy these two nodes like that, and merge this guy in with the others. Copy this guy here like that. We're gonna copy these guys' point and our very last point, plug that in there, and have that feed into the both the complex collision, but also the output of our SOP, right? Because otherwise we wouldn't be seeing anything. And instead of grabbing, the last multiparm entry, or the iteration multiparm entry, what I'm going to be doing is I'm just going to be copying the very last iteration. So to do that, I'll just copy the relative reference and grab this guy and just paste it in here, where we're going to say iteration equals this guy. And instead of it being a string, we want it to be an integer, of course, which allows us to now show us that very last point. And of course, this guy shouldn't be pointing towards, oh, it's updated already. Awesome. Let's hit Control S and save our node type and delete all of these guys. Yep. All right, cool. Let's enter. Oh, I broke something, didn't I? Oh, sorry. Yeah, no, that's my bad. The complex collision geometry, we shouldn't be testing against the last point. We just added, of course. That's dumb. So let's do this instead. Literally just repeated or created the error that I said we'd be avoiding. That's funny. Yeah, so this should be better. Save node type. All right, so click. And now, as you can see, now we have access to all the previous geometry we have and the one that is active, which allows us to now you know, just play a lot more with it. Cool, so that's that. Next up, what are we gonna do? What are we gonna add? Let's add in, what should we do? Let's ask the chat. What should we add in? Should we add in scale, or do you want to see something else? Rotation. What about, let's pick an easier one first, so we don't get into too much math immediately. Let's add in some other cool stuff that we can do with Python state, so that we're not just you know, adding options with the same stuff over and over again. Let's see, what can we add? Oh yeah, another cool thing is instead of just getting stuff from the mouse, we can also actually detect what type of input device it is we're using. So if it is a tablet, right, if we're using, let's say, a Wacom device, we can get the angle that you have your pen at, or the pressure, or the roll, or the tilt, and then we can create really cool drawing tools with that. So perhaps that's something that someone in the chat, you know, once this is over, you know, would like to build by themselves at home. That'd be pretty cool. What about mouse wheel event? Let's take a look at that. So let's create multiple types of objects to be painting with, rather than just a single box. So let's add a sphere, and we're going to be doing the same thing, and make this thing a polygon mesh as well. Place that guy at the origin as well. Let's make it unit size. Same with box. Box is already unit size, but it doesn't matter. Merge this guy in here, and we're gonna just create a wrangle, and we're gonna give it some data that we're gonna be using with the copy to point SOP. So let's call this one let's call it ID. Let's call this one 0. If you know, we would be building an actual production tool, you know, this would be something that we'd automate inside of the tool itself, generating these attributes with like a connectivity SOP or something like that. But for now, let's just do that. Do it like this, and plug this guy in here instead. And then with the copy to points, we're going to be copying using the piece attribute, which is going to be ID. Okay, and that means, of course, that we need to set the value of ID of each point, because right now, you know, it doesn't know what it is. So let's create an attribute wrangle and just say I at ID equals, and on, you know, let's set it to 0 for now, so that we have it working again. But instead of just hard coding it to 0, we're going to be creating a parameter up top that we're going to set. Okay, so let's start with that first. Go to type properties again, and go to the parameters tab, and we're going to be creating an integer. And this guy we're going to be calling and let's call it IID, and call this one ID for what we're going to be painting with. So that already gives us, you know, our ID attribute. And instead of having to look at all of this stuff later on, we're going to create a folder and just, you know, make that a collapsible. Let's see. Someone says selection or copy the stroke swap behavior. I think we'll keep that to the next state, because that's a bit more complex than what this is. The idea that I basically had with this stream is that I'll be showing some basics, showing you how to get started, so you can see how easy it is, so that you can, you know, practice by yourself without having to, you know, start by figuring out how the docs work. Create a little tool yourself, and then later on in a future stream we can make it more advanced and go into stuff like the selectors and stroke states, inheriting auto states, and so forth. All right, so we want to be getting the ID. Let's just add an underscore here again so that we're all nice and consistent. And then we're going to be doing the same thing we did before by just saying, you know, grab the value from up top. We're going to be calling this one ID. We wanted to, you know, grab an integer, and we're going to be grabbing from the ID at iteration. Cool. So now this guy is grabbing our ID attribute, but we of course want to store it. So I'm going to wire this guy into the second input from this guy, and just with a detail function here in Vex, we're going to be grabbing that value by just saying grab me the ID attribute. So now we have that ID attribute, and of course we'll also be needing to update this guy down here. So once again, copy this guy's code, paste it in here. What we could be doing is actually taking this wrangle and copying the parameter and just paste it in here, so that, you know, if I update this one will also automatically update. But for now, we'll just copy and paste it since it's easy enough to do. All right, so we have the ID. Cool. We need to store the ID here as well. So let's copy this wrangle here and wire that one in here and wire that one in here. And instead of that one, we want this one. Let's go up and save our node. And let's just verify that that works. Zero and one. Is that correct? Let me see. Let's add one. Oh, I'm doing something wrong. Let's see. See, now this is why it's awesome to have our debug together, since we have you guys in the chat. What did I do wrong? Let's find out. We have the ID parameter from up top. Well, it seems right to me. Let's see, do we at least have it here? Yeah, so we have ID here. Oh, right, of course, we need this guy to say ID as well. Otherwise, it doesn't know what to copy, would it? Cool, so, all right, cool, that was a dumb little bug. But now, we can basically just, you know, change the object we're painting with our parameter up top. So next up, let's add stuff to our mouse wheel event. So since we don't have that one yet, I'm going to go to my sample code again and just add that guy up here. Add it to my Python state. So now as soon as I modify my mouse wheel, we can, you know, any code that I put in here is going to get run, right? All right, so let's start simple once again to check that it works by moving our mouse. And as you can see, we're gonna get the value of either +1 if I'm scrolling upwards or -1 if I scroll down. So that's going to be useful for us because we want to, use mouse wheel to increment and remove values from this parameter here. So let's add that in. First of all, what we'll be doing is grabbing the number of entries we have again, and use that so that we know which multiparm entry we're dealing with. Then we're going to be copying this guy here because we need to find the actual ID parameter that we're dealing with. So I'm just going to, instead of copying a parm tuple, I want to reference a parm because we're not dealing with a tuple right now, and we're looking for the ID1, and we're going to be calling this one num entries and then plus scroll. Oh, not num entries. First of all, we need to get the value of the parameter, of course. So we're going to say dot eval as int, and we're going to call this one current values equals not values, current value. Copy this guy, paste it in there, and just set it like that. All right, let's see if that works. As you can see now, we have bound our scroll wheel to our ID attribute. So as you can see, now we can toggle between 0 and 1 by just moving our scroll wheel. Of course, we didn't add any limits yet, so we can scroll higher than a value of 0 and 1. We could check how many actual unique objects we have and just clamp it to be either between 0 and whatever value. Actually, let's do that. Let's say max that and 0. That at least clamps it between 0 and whatever value we have. It doesn't make sense to have negative values. All right, cool. So now we have that. So now we can already control that. So if we go to our state again and hit enter, click once, scroll once, and place our sphere. And as you can see, now we can already place multiple types of object. Let's get rid of that print because it's a bit annoying and we don't really need it. All right, so now we have that. Next up, so that was the mouse wheel event. We can of course also check other stuff like whether or not we pressed our middle mouse button down, like the scroll wheel. Do stuff with that, for example. Next up, let's do scaling. That's fun. Because scaling is a bit more complex. It's still easy, but it's a bit more complex than just placing a single guy. And to do that, we want to be grabbing some more code from here by checking if we started clicking down and if we moved our mouse, right? So instead of just clicking once, we want to be checking if we clicked our mouse and just held it down, or if we we're moving with the mouse as well. So add these two guys in, and as you can see, nothing's printing yet. As soon as I click and I move, we can see that I'm holding my mouse, by the way. We can see that it says moving a mouse. And if you think about why I need that, the reason is we're going to be needing to calculate the distance between the point that I started my mouse click on and the position that I'm currently colliding with, right? And get the distance between that. And that's going to be controlling the scale that I have for my object. And then, of course, we're going to change this from picked to be start, right? Because otherwise we'll be getting lots of duplicates. So first thing I want to do is keep track of whether or not we put our mouse down for our click, right? So we're going to say self dot placed object, and we're going to set this to false to begin with. And also I'm going to set this on enter as well, so that we for sure know that as soon as we enter the state, we haven't placed anything yet, which will never be the case. And as soon as we start, we're going to be setting that value to be true. And the reason I'm going to do that is we only want to update or modify the position of our multiparm when we start our press of the button, right? Which allows us to now remove this. Start, yeah, okay. So we can remove this for a bit or get it back later. We want to have the position, yes. So as soon as we start clicking, we're gonna grab or set the position value of the latest multiparm entry, and we're gonna say we place an object. Okay, cool, that's great. Next up, active. Yeah, we wanna get the distance between the start of our click and the end position of our click. So what I want to be doing is I also want to store the position of when I started my click. I guess I could read the multiparm value entry, but I just want to store it. So I'm just going to call this one place pause, and we're going to create this to be a who.vector3, right? So we're just storing an oh, what's happening? We're just going to be creating an empty vector at the origin. And as soon as we start our click, we want that to be set to our hit position so that we know where we hit it. Let's see, 108. Yeah, okay, that's just because we're not doing anything yet. No complaining. Placed object, okay, active. So if we're active, we're gonna first check if we place an object, self dot placed object not equals. Let's see, if self dot placed object equals true, right? It's already true, but I like to be explicit. We're going to be getting the distance from the latest position, this guy here, hit position, and then we can call, I think distance2 is what the name is. Let's see, I saved it down here just in case, or not. That's probably fine. Let's see, the distance from hit position to the placed object position, like that. Let's see. Place path is not defined. Did I not create this up here? Oh, of course. It's just me being dumb. Enter, drag it, and now as you can see, we're gonna move this over here. As soon as we drag, we're gonna be getting a distance between the original starting position that we placed and the position that we're currently colliding with. Let's see. There's some more questions here that I could probably answer. Could you also scale by the screen space distance covered instead of the world space distance? Yeah, you very much could do that. Yeah, you definitely could do that because you have access to the position of the mouse on the screen, and then what you can do is you can store the previous position of the previous frame of the mouse, and then just see what the distance is that you moved between. Same thought for the case when you don't hit anything. Oh, you're talking about that my scaling would stop as soon as I were to move out of my my geometry? Yeah, that's correct. But there's a thing I'll be implementing later on, which I already did for the pick and place tool. Instead of constantly colliding with the geometry that's already there, as soon as you place it, we can actually do another collision check, which we won't be doing against the geometry, but we'll be generating a plane to collide against. So I have some sample code here as well where I show that this guy here. So instead of, we could do that when we don't hit anything, but we could also do that as soon as we place our object down and then collide against a plane that lies on, let's say if we were to, click on this guy here, we would basically generate a plane that would lie on top of this surface with a normal that aligns with this surface here. So that's basically how I did the pick and place tool that I already did, where if I have a curved angle or something that's slanted like that, if I were to move my mouse and drag to the side, all of a sudden it would collide with objects that might be very far away but only lie 1 pixel away from where my mouse is colliding with. So that's why I use that collision plane that I just generated, because then it's very linear and it doesn't jump all over the place. What is the point of doing that collision plane instead of a viewport position then? It's just preference, honestly. The plane as a section just takes less long to implement because it's just this one line of code. If I want to check the movement of my mouse throughout a couple of frames, then I would need to store that and check it against that and calculate the difference between those. But right now, this would just give me that position straight away. I hope that answers your question, Paul. All right, let's have a quick drink of water. Yeah, so we now have our position or a distance. So we're gonna need to, of course, store that somewhere so that our object knows about it. And we're gonna be storing that here in, just do a float for now. We could add things like, a vector 3 scale and then, scale the components individually, add controls to that. But for now, let's just call this one uniform scale. And this one's going to be called fscale underscore and then a hashtag for the number of the entry number of the multiparm, right, as you see there. And of course our default is going to be 1, because otherwise if we haven't clicked and dragged yet, we would get our object to be of scale 0, which wouldn't be a whole lot of fun because then we wouldn't see anything. Next up, once again, do the same thing. We've done this a couple of times already. We're gonna grab this and store it in here. Add scale. We're gonna be grabbing a float. Scale iteration. So some of you might be wondering why I'm doing it in this detail wrangle here instead of straight in here. That's just a preference of mine, honestly. I'm not, you could do this right away here, but it's a preference of mine because I want the data that I have here to be also accessible by other nodes. And like I mentioned earlier, I don't want to be writing HScript expressions to grab, a value or from a parameter name that I'm generating dynamically. So that's the reason I'm using this detail wrangle and sampling from that directly. Okay, so once again, we of course need to add a p-scale attribute. So just call this one f-add p-scale detail, and we're going to be getting the scale from that guy. Let's see, scale, yeah, cool. Spreadsheet, see if that works, is grabbing the right value. And also, like I mentioned before, we're going to need to copy this over to this guy here, because otherwise our very last point won't be getting any of that. Like that. All right, let's check that it works. Yes, so we can now scale our object. Perfect. So next up, we're going to need to set our scale. So we're going to call this guy here scale equals that. And then we're going to be grabbing our scale parameter. It's not a tuple. And we called it f scale. We could, of course, create functions to set all of this directly. But for ease of use and make it easier to read for everyone watching, I just do it this way right now. All right, scale. Let's set that guy to be scale. And now let's see if that works. Probably not yet. I probably forgot something. Oh, it does actually. Okay, cool. So now we have our scale, but where did all of our objects go? Where did it go? Did I forget something? Oh, right, of course. Yeah. No, it makes perfect sense. We're only we're not creating new entries for our. Oh, this is a scale problem that I was mentioning before, by the way, where since we're colliding with geometry that's, you know, it's technically 1 pixel away from this guy here, but if I start dragging, it's going to be colliding with whatever is next to it or on the grid, you know, making the scale jump around. So that's why I'd use that C-plane collision. But first, let's fix that problem of creating a new multiparm entry as soon as we release. And to do that, I'm going to go back to my sample code, and I'm going to be grabbing this guy here, right? The changed, and this guy is going to be called as soon as we release our mouse button, right? Meaning that we're going to grab this guy's code here and place it in there so that we increment our multiparm as soon as we release our mouse button up. There we go. Like that. Perfect. But now we don't have our position being copied anymore. So let's fix that problem. Let's see. If we start, yes, we want to set the position, correct. We place our object. Oh, yeah, of course. We also want to be telling the tool that we can now place an object again. Because otherwise, you know, it keeps thinking that we're going to keep modifying that additional point. But as you can see, we can already add new pieces of geometry and scale them very nicely like that, which, you know, would take quite a bit longer if we were to do this manually using a translate SOP and a merge SOP and whatever else. Yeah, okay. But our object is not updating as soon as we move our mouse. So we're gonna need to figure that problem out too at some point. Are there any questions that anyone has of the stuff that I've shown so far? Alright, doesn't look like there's any questions there. Let's see, let's just look through. I missed the very beginning of the presentation. What is this tool called? This tool right now is just a tool called, what do we call it? Python State Stream SOP, which we built from scratch. But if you want to see the more updated version of this tool, you can create or grab this guy here from Labs. The pick and place tool, which has all the logic I showed and a bunch more already built. So this is literally just building it from scratch. And you can see we've already achieved quite a lot in, how long have we streamed for? A bit over an hour, and a lot of that was me struggling and showing some of the docs as well. So imagine what you can build in 2 hours or a little bit longer than that. Oh, right. I can see why we're I can see the problem. We want this guy to be updating all the time. So if self if our place object equals false, not equals, we want to check it, then we're going to be updating our parameter values, not just when we start clicking, right? There we go. Problem solved. There we go. I just had to think about that for a minute. All right, so let's take a look at that problem that I mentioned, where if we were to scale now, you can see that, you know, our scale is sort of exploding because it's not grabbing the scale from me colliding with the plane of this surface, but with every piece of geometry that you see. So if I were to move my mouse here, if you know, the collision point that it's sampling against would actually be the point down here instead of what it is that we want. So let's implement that real quick by getting a plane that we intersect with, which is this guy here, and add that in here. Scale, where is scale? Scale is here. All right, so instead of when we're dragging, instead of colliding directly with the position, right, the place pause that we have, or hit position rather, right, just the one that we're updating constantly, we're gonna be grabbing or comparing to this guy, which is our new collision. So we're gonna grab the position of a plane that we're gonna be creating, of which the origin is oh, hang on, now I gotta check the docs for that real quick. Place spot. Yeah, okay, that's that. So this is the original collision point, which is this guy here. Place pause. Then for our up, that's going to be the direction of that plane. We're going to be grabbing the normal from the geometry that we're colliding with, right? So we're going to grab from the geometry intersector the normal. So gi.normal. And then origin and direction, we can just leave as is. And that should now allow me to just collide with that that plane I was talking about. See, there we go. Oh, or not yet, actually. Intersect plane. No, this needs to be. Hang on, I gotta double check this. Origin, direction, place pause. This is just the Python state from the other one. Yeah, this should work. Let's see. Place position. Why is this not working? Looking at the chat, see if anyone has a clue of what's going on. That's the fun thing of doing live stream that that we didn't prepare for, right? Or not a presentation format. Scale, base, distance to, distance, place pause. Yeah, I think it's... All right, we're gonna skip this part for now. I'll keep an eye on the chat. We'll come back to this later if we haven't fixed it yet. Yeah, what else should we be doing right now? Right, yeah, that's a good one. That's probably it. The normal that we're colliding with or checking against is constantly updating, because we're not storing the normal of the initial hit. That's a good catch. Splendid specimen. So let's store that as well. Let's let's store the normal as well as an empty vector to begin with. And then as soon as we start clicking, we're going to be storing that as well. Self.hit normal. Hit normal equals. All right, cool. Let's check if that fixed it. Yes, that was it. Nice catch. There we go. Cool. So now that that's working, let's see what else we could do today that doesn't take a whole lot of time. Let's take a look at some right-click menus. How about that? How about that? I think you guys might be interested in that. So with the right-click menu, let's save this guy. Let's do that in a different tool. Let's do that in the trim textures tool. Everyone has access to this node, right? So what I'm working with or going to modify right now, you can just grab yourself in case you want to take a look at it. What I want to do is modify the options that I have here in my right-click menu, so that the behavior that I'm controlling with my mouse button, like the translation or the rotation or the scale, all of these actions, you know, they happen when I middle mouse button down and move my mouse around. I'm not holding any of the modifiers, like for example, T for translate, R for rotate, and E for scale. I want this to just be a one button click tool, right? So that's what this right click menu allows me to do. And same goes for modifying for the translate and the scale parameter, for example, whether or not it is I'm modifying the horizontal scale or the vertical scale. And the way I can do that is by adding things to my right-click menu, to my my context menu rather. So what I can do is create one of those guys. Let's copy the sample code and then we'll go through it in a little bit. And we're going to do that here where we are. Oh, where's my my Python states tool? Let's go back to our other version, this guy. Scroll down. We're going to be doing that here where we create our viewer state template. And just right in between us returning the template and where, you know, we're binding the factory and initializing a lot of other stuff, we're going to be adding this code here. And what we're doing here is first create and bind the context menu to the state, right? So what I'll be doing is just creating a new menu entry first, so viewer state menu. And then we can add a couple of things to our menu. We can add some, for example, a toggle, or we can add a radio strip and some properties of the radio strip. I'm just going to comment this out because I'll talk about that in a bit. So if we were to save and enter our state and right click, we need to bind it, of course. Template. Hang on a second, I need to read this for a minute. Is there no menu? Yeah, we need to bind our menu first, of course, with this guy here, which is the piece of code that I forgot to copy, of course. So we did create our, yeah, it's gonna be complaining about, some code here. So what is it we're doing? We're first creating our menu, the right-click menu. We're adding a toggle. We're adding a radio strip, which can hold radio strip items, right? The little round buttons. And then we're gonna bind that that menu to our state, because otherwise the state doesn't know about it. So by right-clicking, we can now see that we have this toggle, which we can press. And we have one entry here in our radio strip menu. So let's do some stuff with that and see how we can get the values from that. So first thing, yeah, sum toggle, that's fine. We can just keep the name for that. We of course want to add some more entries to our radio strip section, and we want to have first of all in here which radio strip is it we're adding stuff to. So in this case, this radio strip is called radio strip section, and then the label and the title for that. And then this guy here is which value is the default of my right-click menu. So we shouldn't be having all of our return values be the same. So I'm just, for simplicity's sake, I'm just going to call this one 0, 1, and 2. And we're going to call this one 1, this one 2, and this one 3. Return. Yeah, okay, we didn't update our default value, of course. Python states doesn't know which one it is we want. So now, as you can see, we have this menu. So how do we do something with it? How do we, for example, modify our behavior as soon as we click one of these options? Well, that's what another one of these callback functions come in handy, which is this one here, the on menu action. So we're going to copy this one from my sample code, and we're going to add this guy to my Python state. Just add it somewhere in the middle, easiest for now. And to visualize what it is we're working with, I'm going to print the menu item and the entry of it. So this one is the menu item, right? This one is going to grab whatever it is that just changed. And this one allows us to grab a specific value of one of the entries. So we didn't just call it something, we gave it a specific name. We called this toggle some toggle. So we want to get the value of the thing that it's called some toggle, because I specifically want to have the value of that thing. And let's just add it in there and then test it. So if I now click one of these radio menus, we can now see that we're going to get whichever radio strip section it is that we modified. And we also get the value of this toggle, even though it's not the toggle that's updating, right? So as you can see, we're getting the value of that. So what this allows us to do is, in this on menu action, change the behavior of our states, right? So if we, for example, change or store the properties of that menu in our state, for example, self dot toggle value, and we're just going to call this one, we're going to give this a value of 0 by default, then we can update that value and refer to it in, for example, our on mouse event, right? So that if we move our mouse and we want to decide what behavior it is that we want to modify, we can check what the value is of some toggle that we just modified, or which radio button it is that we picked. So then we could, for example, say self dot toggle value equals, and then this guy here. There we go. Save that. So that now, as soon as we modify our toggle value, we can store it in here. But we could, for example, also do a check in here. So if we say if the menu item that we just got equals, and then the name of the section that we modified. If it is the toggle that we modified, we can, for example, say user touched toggle. And then it will only print that if we change the toggle. It won't do that when we change any of these radio buttons. So that allows you to bind some behavior to whenever it is the user does something directly. But that's not really useful right now, so let's just remove that. Any other questions? Let's see. I am curious if you can check the collision against the object you're adding rather than just checking against where the mouse is so you can avoid intersection with already placed objects. If you can check the collision against the object you're adding. So you're talking about the box that I'm currently moving, right? Why would I want to check or collide against the box that I'm currently moving? To avoid the box in a box. Well, the whole point of why we added that this behavior in here, or this logic here, where we first, create all the points except the last one being the one that we're moving around, and the terrain, is so that we can collide with everything except the box that we're placing. And then after or before we showcase it to the user or show the output, we then grab our very last point and just copy one box onto that, so that we're not colliding with itself. Because if you look, we're not colliding with that box. See? We're only colliding with whatever it is that's last. Because then we can do this kind of stuff. All right, let's do one last thing before we end the stream. So remember how I mentioned in the beginning that we're adding a multiparm entry as soon as we enter our state, and then as soon as we leave it, we don't remove it when I haven't placed it yet. Let's implement that last thing before we end the stream, which should be a pretty easy one. So in our on exit, let's copy that guy from here, which is the function that gets called as soon as we exit our state. We want to be removing that last entry of the multiparm, the last entry of the multiparm if we haven't placed an object yet. So first, let's check if we place an object. So if our placed object equals false, we want to be grabbing the number of multiparm entries and that's that. And this time I'm not going to forget self. Okay. And then we're just going to set the multiparm to be multiparm entries -1. And we're only going to do that as if we haven't placed an object yet. So let's save that and let's see if that works. So we have our node, we exit it, and it's going to delete it because we haven't placed it yet. Let's place an object and leave it. And as you can see, it doesn't remove it because we only placed that last object. Cool. Yeah, so that's what I wanted to show for this stream. Next time we can look at binding handles, doing selections, and perhaps some more cool stuff. What I would like to do, however, before anyone else leaves, I can share this tool. I can probably just add it to Google Drive and add it as a link to this stream. What I'd like you to do, for those watching and are interested in creating stuff yourself, try and modify this script so that you can set the rotation of the object, right? So that whenever you move your mouse around the object or the location that you've initially clicked, it needs to orient the box towards that position. Okay, I'd like to see people do that, or perhaps some other cool stuff. Another cool challenge is getting the box to align with the surface that you're colliding against, right? So what I mean by that is, is this, where if we place a box, so first of all, this is the rotation one, that we get the box to be growing on the surface that we're colliding against. Okay? Another cool thing that I'd like you to do, if you want to, is implement snapping to see how your knowledge is of the right-click context menu. Yeah, Mike, homework. I know you love it. Yeah, I think that's what I wanted to show. To help you along, this is the link to the Python states document, or the documentation. So SIdeFX/docs/Houdini/state_Python states. You can also just find it by going to Google and typing Python states Houdini, and you'll find the documentation here, which of course, tells you about the nodeless states, the selections, the handles, parameters, interface events, which is all the stuff that I showed today, like the right-click menu, key input, perhaps even tablet. Or it would be cool if someone tries using a tablet, if you have a tablet at home, and intersecting objects. Yes, that's a good point. You can also go to the installation of Houdini. Let's go to SideFX software. Oh, let's not look at that. Houdini, and then go to viewer states. Or is it viewer states? Examples. And these were all the cool examples that Marc-Andre, the developer, has been building. So you can check those out. Actually, before I stop, let's take a look at those. See if there's some cool ones there. Let's look at the let's do the advanced drawable. I think that one was really pretty. All right, so technical desktop. So just ignore all the complex stuff. Let's select our node and hit enter. And as you can see, this is quite a more complex state because it uses advanced drawables. But this allows us to draw selections on geometry. And by, for example, moving the scroll wheel, we can increase the selection over geometry. We can render text on the screen. We can attach text to our cursor, for example, or attach geometry to our cursor. We can change stuff like, the values of these things, like the highlighter of the text. There we go. Can do some really cool stuff with this. Fade factor. Let's see, what's this? Color 1. Oh, I'm looking at face mode. Okay, yeah. Yeah, so you can draw, point highlighters and all the cool stuff like that. Lots of cool stuff. Let's see, sphere vectors. Yeah, we can also draw vectors in the viewport. Let's enter this guy here. So what's happening here is we're just drawing these arrows in the viewport wherever we want it to be. So instead of generating geometry that lives in the nodes themselves, we can generate these arrows as drawables and just render them in the viewport as well, which is really cool. Let's take a look at another example. Bend. Let's see that one. I haven't looked at this one. Oh yeah, okay. This is just the bend state. So the new bend SOP that we have in Houdini 18 is actually also a Python state. It's implemented through Python state. And to see those states, or all the states that ship with Houdini, we can just right-click or click on this little plus button, go to New Pane Type, and under Inspectors, we can click Viewer State Browser. And in here, we can see all the Python states that already got implemented in Houdini. And like, for example, the camera, which is the default state. This one might not be Python, but it's still a state, so it listed here. We can take a look at all of these and just hit Edit, so we can see the Python state itself. Or if it's a nodeless state, we can even enter it. right? So for example, for let's see if we have a nodeless state in here. I don't think we have, but if you want to see an example of a nodeless state, you can go to the SIdeFXLabs GitHub and check out the viewport measure tool that we ship. So if you go to the GitHub page and go to the viewer state node here, this node that we see here is actually a nodeless state. So to show that, I'm just going to copy it real quick. And let's get my shelf back, add a new shelf tool, add a script in there, just paste it like that, accept. Oh. And now when we click that, we should be able to get into that tool. Oh no, we need the Python code to enter this state first, which I think I have somewhere here as well. Either way, I'll show that next time. This is an example of that nodeless state, right? Where you can see that I don't really have actual nodes that I'm setting parameter values of. This state is just grabbing whatever geometry is currently being rendered in the viewport. And then once I click and drag, it is going to measure the distance between my start drag and my end drag and render a line between it. So that's another example of a drawable where I'm just generating and drawing geometry just in the viewport without it actually existing in the viewport. So that allows me to create really cool states like the measure tool that I could then bind to, for example, or save it here on the shelf and then bind that onto a hotkey so that I can enable that anytime I want. Okay, let's look at questions. Can we write an essay on Python states for bonus credit? Yes, yeah, you can, Maitland. You can do as much as you want. Is there a way to do a raycast from the placed position to find the maximum size placed object can to prevent it from interpenetrating other geometry? Or would I just have to call that intersect function button? Oh, not button, but a ton of times. Yeah, I guess what you could do is from that place position, do a bunch of raycasts outwards in a sphere, right? Just sample some directions in a sphere, do a raycast, giving you the maximum distance between the place position and whatever it is you're colliding against. That could limit your p-scale, for example. Another thing which you could do, but would be a lot heavier, is use Boolean itself and see if when you use the intersect mode, if there's any geometry being generated by the Boolean. You could probably just run Boolean as a verb instead of it being a node in the network. Right, cool. I think those were all the questions. So I'll be ending the stream here. Thank you all for attending. I'd love to hear what you think about this stream. Was it useful to you? Did you learn some more about Python states, or is it getting you excited about it? And also just curious in general, how do you think my first stream was? Yeah, awesome. Thanks for participating. Take care.